Let's talk about making solutions. So chemists and scientists of all stripes have to do this constantly. And so let's just talk about practical stuff. Okay, so when I'm asked to prepare a solution of a certain molarity, I really focus on, okay, how many moles of solute am I going to need, full stop. How much solute do I need? And then if it's a solid, I'll need to go from moles to grams. And if I'm going to measure out a liquid, then I might use density to get to volume. So here's an example. Let's say I'm trying to make a perfume, and so I'm trying to make 100 milliliters of a 2 millimolar solution of geraniol. Okay, how many moles of that solute do I need? Well, I need 0.1 liters. So let's start there. And the solution needs to be 2 millimolar. So that is 0.002 moles per liter. That's 2 millimolar, right? Okay, so liters cancel out, and what I get is 0.0002 moles, or 0.2 millimoles. Okay, so great. Now I need to convert moles to mass. Well, I don't know the molecular weight of geraniol offhand. I could count up carbons and hydrogens, I guess. But you know what? Let's just look up Wikipedia. That sounds like a good idea. So I am going to pull it up. I type geraniol into Google. Here it is. There's the molar mass, 15425. Cool. So here we go. Times 154.25. Hope I didn't forget it in the literally 3 seconds between looking it up and writing it down. Here we go. Moles cancel out. Dit. And then I got to do some math. Okay, I went back and did some math, and this is what I have. 0.03085 grams. Couple extra sig figs there, not a big deal right now. Because I also know that geraniol is a liquid. How do I know that? Well, two things. A, I've used geraniol a lot and I know what it smells like. It smells like geranium, so I know it's a liquid. But also how I know that is Wikipedia, because it does give me the melting point and the density. Let's go back and check that, right? I don't know if you guys have heard about Wikipedia. It's actually pretty slick. Right, so here, this density says 8889 kilograms per cubic meter. If you actually do the conversion of grams to cubic centimeter or milliliter, that's going to be 0.889. So let's write that down. Okay. So here's our math. Here's 0.03 grams geraniol divided by the density, 0.889 grams per milliliters. Grams cancel out. Millimeters comes on top. I have to go use my calculator again. Hold on just a second. So if you do all this math, you need much less than 1 milliliter. You need 34.7 microliters of geraniol to get a 100-meter solution. So I would probably use a biochemistry pipette out that little tiny bit, and then just dilute it to 100 milliliters. Other times, we will be given a solution of a given concentration, and we'll just be asked to dilute it. And this is where some people just kind of memorize an equation, M1V1 equals M2V2. I don't like memorizing stuff when I don't have to. I like thinking stuff through. So again, I'm going to how much HCl am I actually talking about here? So I'm going to multiply just like I did before. 100 milliliters is still 0.100 liters times 2 moles per liter equals 0.200 moles. Nice. Okay, so that's how much stuff I have. If I'm going to dilute it to a final solution volume of 1 liter, then it's just 0.2 divided by 1. So the final density, the final molarity is 0.200 molar. Again, could I have plugged this into my old standby M1V2, M1V1 equals M2V2? Sure, right? 0.1 liters times 2 molar equals 1 liter times 0.2 molar. That works. But when I'm thinking about solutions, again, I'm really focused on how much of the solute is actually in there, and I'll solve it around that. Stock solutions. So this is a kind of true example from my own research program. So we are working on trying to make new antiparasitic drugs, and we prepare 10 millimolar stock solutions to send them to Europe for testing against the parasites. So I'm constantly doing this math my own self. And lots of people I know have to do stuff like this a lot. Okay, so how much of a 10 millimolar stock solution is required to prepare 5 mils of a 50 micromolar solution? Again, I want you to focus on how much stuff is actually in the solution. And I didn't even specify this time, but let's just say solute. So if I need 5 moles of a 50 micromolar solution, micromolar is micromoles per liter. There are 1,000,000 micromoles in 1 mole, so it's 10 to the 6. So converting liters to milliliters and micromoles to moles, I end up with 2.5 times 10 to the negative 7 moles of solute. It's about 1/4 of a micromole. Okay, that's a really, really small number. So my stock solution is kind of dilute. How much of that stock solution am I going to need? So for that, I'm going to divide that solute by the concentration of my stock solution, 10 times 10 to the negative 3, or 1 times 10 to the negative 2, I guess. Either way, it's going to be, the answer is 2.5 times 10 to the negative 5 liters. Seems like a small number. It is a small number. I'll need 25 microliters, which is easy enough to measure with a syringe or with a biochemistry pipette. So again, I will measure out 25 microliters of the stock solution and then dilute that to 5 mils with solvent. Okay, so those are 3 examples of how you can make solutions. From just simple get the stuff and then dilute it, in this case geraniol, to diluting another solution in its entirety, and then on to stock solutions.